Hello, in this section of the video today, I'm going to be telling us the shapes of molecular compounds, metallic bonding, factors affecting metallic bonding, properties of metals. Let's proceed. Shapes of molecular compounds. Molecular compounds have different shapes as a result of the interaction of the reacting species and a factor we call hybridization. Hybridization of orbitals is a process whereby orbitals of different shapes and geometry combine to form an orbital of suitable geometry which can allow maximal overlapping during bond formation. And because of hybridization, molecular compounds take different shapes and configuration. For example, the shape of methane, CH4, having one principal atom of carbon and 4 atoms of hydrogen covalently linked, is found to be tetrahedral in shape. While ammonia, having one nitrogen atom and 3 hydrogen atoms covalently linked, is trigonal pyramid in shape. Other compounds like carbon 4 oxide is linear because of hybridization, whereas compounds like hydrogen fluoride, water, are bent in shape because of the interaction of the reacting species due to hydrogen bonding. Water and hydrogen fluoride forms several hydrogen bonds interlinking each component, giving it a bent shape. Furthermore, metallic bonding. Let's discuss briefly metallic bonds. Metallic bond is a special type of bond found in metal crystal lattices. One interesting thing about metallic bond is that it does not result in the formation of a new molecule or material. Rather, the metal atoms are held together in a subtle in electrostatic force of interaction because of the displacement of electrons to the what we call the delocalized electron sphere, causing the atoms to be positively charged and the delocalized electron sphere to be negatively charged, resulting in a bond having a partial or an electrostatic configuration. Metallic bond is responsible for the metallic properties of metals.